Thank you, and hi everyone. So what I'm going to talk about today is ColPali. So the ColPali is a model and a method to perform. Oh yes, thank you. To perform efficient document retrieval with vision language models. So this is a project between the company I'm the head of research and development of, so Ilvin Technology, and an academic lab at Centrale Supélec, a French engineering school. The project, the lead author on the project was Manuel Feis, but was not available today, so I'm here. The underlying problem is the following. We know that RAG is the #1 business use case for generative AI currently, to us at least. It's a very powerful method, but a challenging one. So I don't know if you know the main pipeline behind that, but we have a set of documents, and we are going to store them into a database with the chunks and vectors. And we have a query that is asked, and we retrieve the top K relevant chunks that we feed to an LLM, and we get an answer. So that's the standard pipeline for RAG. But it's a very challenging one for many reasons. The first one is that in a standard RAG pipeline, we use several models. So we can use OCR models, layout detection models, table figure detection, etc. A lot of models. And then we can even possibly caption figures. We can chunk the different paragraphs, etc. So that's a lot of operations. And we actually are making a lot of mistakes that build up on each other. And these pipelines are very complex and slow. So what we propose is that to use vision language models to adopt a new strategy for RAG. So a vision language model, it's very simply a model that takes as inputs a text, like a query, so like what kind of dog is it, and an image, so the image of a dog. And the vision language model is going to give a reply, an answer. So it's a Labrador. What we are going to do is that we can use these models for various tasks like captioning, natural image, parse the results of documents, or even use vision question answering on complex figures. So what does it look like, standard VLM architecture? So we have a vision model. So here it's a SIGLIP model that takes an image, encodes it, and then there's a linear projection that encodes the image into the same space as the tokens of the language model. So we have the vision model on one part and the query on the other part that are both fed to language model. So here it's GEMA. Because it's the PaliGEMA architecture that was the first one that we use for the ColPali model. So it looks like that. And what we propose is to rethink the strategy for the RAG pipeline. So instead of having a standard pipeline that work on extracted textual content, we're going to train retrievers that work and using the document image. So now we are comparing a query not to chunks of text, but to images of documents. So that's the new approach. And it's it's more performance, it's faster, and it's a trainable approach. So these are many advantages. What we've done is that we first design a benchmark. So it's called the Viaud benchmark, in order to assess the relevance of such an approach. So we've used academic data sets that you can see on the top of the table, and also industrial documents that are more relevant to our specific applications. So in different domains like energy, government, healthcare, AI, and environment. So this data set is really to assess the relevance of the approach. What does it look like? It's the image of a page, and associated to it, there's a query, like for this page, what types of accounts or products allow investors to defer paying taxes? So we have, I don't know the exact number, but several hundred types of such queries. So I'll go a little bit further. So what does it look like, the ColPali approach, in terms of pipeline? Before, at the top of this slide, you have the standard retrieval approach, and at the bottom, ColPali, ours. So now we are going to take the image of the document. We are going to divide it into patches for the image. We're going to use the VLM and feed these patches to this VLM. And we're going to have several embeddings for each page. And we are going to compare them to the tokens of the query via a late interaction system. So what we're really doing is that comparing the image to the query directly. So as far as training is concerned, we trained ColPali for industry-oriented use cases with LoRa adapters for the LLM weights and in-batch contrastive loss. So going a little bit further, yes, training details. So for the first version of ColPali, we've collected 130, more or less, 1,000 pairs of query page for the training. We've trained that on one epoch for 8 AMD GPUs on Adastra, a supercomputer in France, for just 5 hours, and it cost only $300. So that was really interesting to have such a powerful model with a very low budget. Okay, so moving on to the results on the benchmark we've designed. So there's a lot of numbers. I'm not going to dive into all of them, but just for you to have an understanding of what happens is that you have all these different data sets as columns, all the different approaches that we've tested as rows, and ColPali is there. And it's actually much better than standard contrastive VLMs like SIGLIP, notably on, well, more or less all data sets, but on academic data sets and also industrial ones, given that Shift is a data set where it's very textual. So it's normal that standard constructive VLM is not very performant in that. Also, we've tried a standard approach where we've used ingestion framework like unstructured, plus captioning capabilities of very performant models. And we've used a BG M3 approach for the retrieving. And this approach is actually, so ColPali is actually much better on the visual datasets. And we do not lose any performance on the textual datasets. Something that we might have had if the vision capabilities were introducing some kind of bias. So on this Shift dataset, we are at the same performance as textual approaches, which is really good. Okay, so the main conclusion is that ColPali was a much better approach than all the standard pipelines that we had before. It's also very simple and fast, notably for indexing. Okay, I'm going to continue a little bit further. So yes, one point that's very important as well is that this late interaction mechanism allows us to compare each token of the query to the different regions of the image. So that's very interesting in terms of explainability to understand what parts of the document were matched to the query. So this is also a very good advantage of this approach. Okay, so I've talked a lot about retrieving, but the idea behind that is to perform visual RAG, end-to-end visual RAG, where we then feed the different images to a vision language model so that it answers to the queries of the user. So very standard.
Okay.
Okay, and there's several improvements that we can talk about. So we can have dynamic resolution with ColQuent2. So I've described the PaliJama approach before, but we've moved on to newer models. We can also have smaller models with the ColSmall family that was released by Hugging Face. And we can also improve the performance. So by tweaking the loss, increasing the training data sets, etc. A lot of things to do. Maybe I'll move a bit faster. Yes, something also very important is that we've designed a second version of the Viaud benchmark. It was a very good start, but it was actually relatively easy for the models. And in the V2, it's actually much harder, and the performances of the different RAG models, visual RAG models on this benchmark is much lower than before. So like we lose something like 30 points approximately. We are also in the process of constituting another benchmark, a V3, that would be even harder. Okay, so just to tell you, it's an open source project. So we've released everything for the first version of ColPali so far, like model checkpoints, leaderboards, evaluation benchmarks, code bases, etc. It's an MIT license, and we're in the process of working on the second versions of ColPali. It's a very active research topic. We've had many contacts and partnerships with all these actors. And so if you're interested to discuss ColPali as well, feel free to get in touch. Thank you very much.